What's up everyone, Mwila here, back with another video. I recently got a request to demonstrate how to create CI/CD deployments to EKS and AKS, so that's what I'll be covering in this video. First up, let's have an overview of everything that will be covered, because there are different aspects or components to this. If there are specific items that you're more interested in, feel free to skip ahead to those points using the timeline. As usual, I'm working with my go-to Node.js application, which will be containerized and pushed to Docker Hub. I'm using Terraform to create the infrastructure for my two-stage pipeline, which consists of AWS CodeBuild and CodePipeline, as well as the Kubernetes clusters in AWS and Azure. The Git repository I'll be using is stored in GitHub. My application will be tested, built, and tagged during the CI stage. Once that's done, as part of the CI stage, I'll clone the repo with my application's Kubernetes resources and use Kustomize to update the relevant manifest files with the new image tag, and push those changes to the remote repository. Once that's done, my GitOps tool, Fleet in this case, will notice the changes and deploy the relevant Kubernetes resources to my downstream clusters. Because GitOps is a big part of what I'll be demonstrating, I want to take a moment to talk about it. GitOps brings together the source code management of Git and the philosophies and practices of DevOps. The desired state of your infrastructure is declared using infrastructure as code, which is stored in a Git repository. The associated platform, Kubernetes in this case, will reconcile the differences between the actual state and the desired state. This declarative model really complements GitOps. You can make use of GitOps tools like Fleet, Flux, or Argo CD to watch your repositories and the state of your downstream clusters. And the tool that you're using will make sure to update your clusters to the desired state defined in the repository when it detects any changes. So I've switched over to my editor over here, and I'm going to take you through the different parts of this solution, from the application source code to the infrastructure as code and the customization configuration files that I'll be working with to modify my Kubernetes manifest files. We'll start off with the Node.js application, and if you've worked with Node.js before, then what you're looking at over here will be very familiar to you, and you'll also recognize that it is very basic. This is totally bare bone because it's not the main thing that I actually want to be focusing on. The main point for this particular video is to actually just demonstrate a GitOps flow for CD deployments or CI/CD deployments to your Kubernetes cluster, and just show you the full journey. Hence me actually starting at this point. So I think it'll still be good to get to see things come full circle. And so I just have a single route, and is the test route over here. If you've watched my previous videos, you've probably seen this. And as you can see over here, I just return a response simple node app working. So this is all I have for this Node.js application. I do have a test for this, and the reason why this is important is because during my CI stage, I actually want to make sure that the test is passing, and this simple test is just going to make sure that I get the expected response when a request is made to the test endpoint. So I should see a response status of 200, and I should get the required text for simple node app working. Okay, so as you'd expect, I am containerizing my application, and here's the Dockerfile for it. I'm making use of Node 14 Alpine, and you can see over here that I set the particular working directory, user source app. These steps should look familiar to you if you've worked with Docker files before, and if you haven't, I will just go through it line by line just so you understand what's actually taking place. I set the base image for my Docker image, and then I set a working directory. I copy over the package.json file and a couple of other files that are important, especially for the dependencies, because as you can see over here, I'm running npm install, and this npm install command is going to work based off of the package.json file, which specifies the different dependencies that I actually want installed in my application. Then I copy over the source code, and then the next step is to inform Docker on the port that my application will be listening for traffic on. And then after that, I just change the ownership permissions for the working directory. And you can see over here, I'm using the user node. And the last step is just to specify the command for getting my application up and running. And you can see over here it is npm start. So this is the Docker file that will essentially define my container image for starting up my container. So that is the application source code. Next, we're going to have a look at my Terraform source code, which is what I'm using to provision my infrastructure inside of the AWS account. And what you have before you is the main.tf file. And inside of my main.tf file, I have a module over here. And modules are just logical groupings of related resources. So because I am provisioning a pipeline, and that pipeline consists of several different components or pieces, it works better to actually just group them together because they fit into a more holistic picture, which is my back-end pipeline for the Node.js application. So you'll notice over here that there are a bunch of different properties that are being populated. Let's start off with the source. All right, so the source is basically just pointing to the location for this particular module and where all the resources actually being defined. So because they're local, you'll see over here that my lead points to a local folder called backend pipeline over there. Your source can be a remote repository for a particular module. And then in addition to that, all these different properties over here are actually variables inside of the backend pipeline folder defined here in this vars.tf file. And so you can populate them at the module level as well, or you can have default values set inside of the backend pipeline folder as well. So what I'm doing is I'm providing the application name. And in addition to that, just populating a couple of other properties over here, such as the pipeline bucket name, the CodeBuild bucket name, and a lot of these things will become a lot clearer as I go through this. And because the source for my pipeline is in a GitHub repository, you'll notice over here that I'm specifying the profile for my GitHub account. In addition to that, the repository name, because all of this will be useful information. And then we have a branch name, the environment, which you don't need to define, but I think it's just cool. I'm basically working off the idea that this is for a development environment. And then these last three over here, the GitHub token, my Docker Hub ID, and the Docker Hub password are sensitive data that I'm actually storing inside of Secrets Manager, but I'm able to reference them using this data property in Terraform, and it will be able to fetch them because Terraform will essentially be making use of the profile that I configure it to use, which has the permissions to pull this information. And so it'll be able to get the GitHub personal access token, which I will need for CodePipeline in order for it to authenticate and have the right permissions to pull all of that source code down for the source stage of my pipeline. In addition to that, I'm also going to be making use of my Docker Hub credentials because I will want to build and tag my image and then push it to Docker Hub once I've got a new version that needs to be released. And so that is what I'm doing essentially with these data properties at the top over there and populating them here at the bottom. Now, something I also want to mention is you'll notice that in some of the cases, I'm just using text or string data for like the GitHub org and the repository name, but the others are actually making use of variables such as the application name, pipeline bucket name, branch, and environment. So these are actually being defined at a root level variables file, which is over here, variables.tf, and you'll notice that this is where I've actually got my profile variable being defined, my region, you can see a couple of values, application name, the environment, the GitHub secret, Docker name, Docker secret name, etc. And so these are the variables that are actually being referred to at this level over here, just so that there's no confusion around that. So they're at the root level, at the same level as the main.tf file, and by root I'm referring to root for infrastructure as code. Okay, so I'm going to close that. And now I want to draw your attention to the backend pipeline folder and the resources that are being created in there, because this is where the real meat actually is. So I'm going to start off with the CodeBuild project. And CodeBuild is essentially an AWS CI tool. So this is where my continuous integration is actually going to be running. And it is just basically a container that spins up inside of a virtual machine. And you can configure it to have the relevant environment setup that you want. You can install any packages or software dependencies that you want in order for the build process to go as you would do it even on your local machine. And so what I'm actually doing over here, providing it with some of the basic information that you would expect, just giving my project a name, give it a description. It has to be associated with a service role, and that is an IAM service role, because it will need to have a trust relationship with CodeBuild, as well as have specific permissions on what it can actually do. And I will show you that in the IAM.tf file. In addition to that, I'm just defining a couple of other things. The important one I want you to see would be, well, actually the source is a really good one to take note of. So because my CodeBuild project is actually going to be part of a code pipeline tool or resource rather that will be created. That is what I'm defining as my source. And then very important is the buildspec.yaml file, which we'll take a look at a little bit later. And this is basically the configuration file that CodeBuild makes use of to know what environment setup it should have, what software dependencies it should be installing, and the different phases of the build as well. All of that gets defined inside of your buildspec.yaml file. In addition to that, you can configure some environment variables, and we have some really important ones. As you can see over here, so environment, as I mentioned earlier, I'm just working off the idea that this is for a development environment. So my env is just going to be dev, but I'm also providing my GitHub token and my Docker credentials because those are going to be, I'm going to be making use of those inside of my CI build stage, and that'll become clearer when we go through the build spec file in detail. And then also very important for the environment step, you can see over here that you can actually specify a compute type that you want for your code build, and this will depend on what your particular requirements are. You can also specify the image that you want to make use of. You can provide it with a custom image, but I'm just going with the CodeBuild, I think version 4 image is the one that I'm making use of, and it is a Linux container. At the bottom, just have a couple of tags, and this is just a good practice for identifying your resources and giving them, just a good form of, describing what they're actually used for. Okay, so that's the CodeBuild project, and as I mentioned, the CI project actually fits within the pipeline as a whole, and I'm making use of CodePipeline, which is a CI/CD tool, and that is offered by AWS, and similar to CodeBuild, I'm providing it with a name. And then with CodePipeline, you're also going to have to make use of a service role. So very similar to the way CodeBuild would also have a service role. It's a particular role that this resource will be making use of to have a trust relationship with CodePipeline as an AWS service, and then have policies attached to it with the specific permissions on what it's actually allowed to do. And then I have a bucket for my artifact store, and I think I actually missed a really important step that I should mention with CodeBuild over here. You'll notice that there's this property called cache, and this is really useful because installing of dependencies usually takes a while, especially for the first time that your pipeline is going to run. But when you have a bucket configured to store your cache, then the process goes a lot faster because all of those dependencies are actually cached as you would expect with this particular property. So that's super important over there. And then the S3 bucket for CodePipeline is just an artifact store in the case that you want to actually be storing your artifacts through the code pipeline process. Now, my pipeline is a two-stage pipeline, and so the first stage is the source stage, which is actually getting all of its source code from GitHub, which is why you'll see over here that the owner is a third-party, provider is GitHub, and I'm providing it with some configuration detail. The GitHub, the owner is my profile, which is Luke Mwila. So if you think back to the main.tf file and how you saw my name over there under the GitHub org variable that was being declared, and then just provide it with the repository name so it actually knows the repo to be getting from. I wanted to poll for source changes, so this means anytime that there's a change to the repository for the specific branch that I want, then CodePipeline will actually trigger the pipeline to start off. And lastly, there is the GitHub token. So that personal access token, which is stored in Secrets Manager, I'm providing it to CodePipeline because it will need that in order for it to actually authenticate and get the relevant source code. The next stage is the build stage, and we just had a look at the CodeBuild resource that is being created, and this is where that CodeBuild project fits in. And so this is just my build stage that I'm defining. You can make use of other build tools like Jenkins with CodePipeline, but I'm just sticking to all the AWS tools for this, and just specifying the running order for this. And lastly, similar to CodeBuild, I'm also just providing some tags over here. So it is pretty straightforward once you get used to working with it. These are the necessary configurations for the two-stage pipeline. And then lastly, I'm just going to show you the iam.tf file. And inside of here is where I'm specifying or declaring my service roles, both for CodePipeline and for CodeBuild. And so this is where I create my IAM role. And then in addition to that, I have a property over here for the particular service role that I want to create, and assuming a particular role and creating that trust relationship with this service role with CodePipeline, as you can see over here. And then the next step is to attach policies to that particular role. And inside of that policy is where I add the relevant permissions. So in this case, I'm giving it full access to S3, and I'm also giving it access to CodeBuild for it to start, stop a build, and as well as to get build information. And I want it to only be able to apply this with any CodeBuild resources in the EU West 1 region. So look, if you're going to be doing this in production, I should advise that you should narrow things down a whole lot more than this. So you don't necessarily have to follow this exact same model that I'm following. This is, you wouldn't want to have these kinds of open permissions in a production kind of environment. Then the next is the CodeBuild service role. Very similar. You establish a trust relationship, and it can assume the role with, and we'll be able to have a trust relationship with this CodeBuild, with the CodeBuild service. And very similar, I'm attaching a policy with the relevant permissions for it. And I want it to be able to have access to CloudWatch so that we can see the logs coming through when we actually look at it. And then in addition to that, as I mentioned, it's a container running in a virtual machine, and the compute service for AWS is EC2. So hence the need for a lot of these EC2 permissions that are actually being granted over here. And once again, you can specify the resources for EC2 and logs. I'm narrowing that down to the EU West 1 region. You can open these up a lot more, but as mentioned, a best practice is to make sure you're following a least privilege principle so that it only has access to what it needs. And then lastly, I'm also giving it full access to S3 and CodeBuild over here as well. I've got a lot of CodeBuild permissions because I want this service role to be able to carry out a number of actions with CodeBuild so I don't run into any issues during the CI stage. The last step would be the S3 buckets, and inside of the S3 buckets, I have my pipeline bucket, which you saw I was defining inside of CodePipeline, and that's for the artifacts. In this case, we actually won't be storing any artifacts, but I hope this can at least show you how you would set it up in the case that you wanted to do that. With my pipeline, I'm actually just going to be building out the container and then pushing it to Docker Hub. I'm not going to be storing it inside of this S3 bucket. And then lastly, we have the S3 bucket for the cache. And so any of the dependencies that are installed during the build stage will get stored in this S3 bucket, and this will be used as cache for any subsequent builds so that it goes a lot faster. So now we're going to have a look at the customization side of things and the build spec configuration file. For starters, you can draw your attention now to the customizations folder, and inside of here I've got my base and my overlays, and inside of my base I have the main resource that I'm working with, which is my deployment configuration file. And I want to draw your attention to the spec section of this manifest file, and under here you'll see the container configurations, and this is the same application that I showed you earlier, the express test application. You'll notice that I'm actually not specifying a particular version tag over here, which is not what we want. We want to be working with specific tags, but this is fine because inside of our base, this is the template for what we're actually going to be building out for the different environments. In this case, just for the development environment. Now inside of base, we also have a base customization.yaml file, and you can see I'm referencing my deployment.yaml file as the resource, and then I specify the customizations that we actually want to make to this deployment file, and it is going to be the image tag to be specific. So I do provide the image name, and specifically you can see over here we've got new name and new tag. New tag is currently set to latest, which is not what we will want. You want to make sure you're specifying a particular version tag. But like I said, for the base, this works totally fine. We're actually going to be building out or exporting our main manifest files using the overlays. And so inside of the overlays folder, we've got a folder inside of that called dev, which also has a customization.yaml file. And it looks very similar to the base one, except Instead of specifying the deployment.yaml file, we are referencing the base, so we'll be able to make use of that. It has visibility of it, whereas base doesn't have visibility of the overlays. And inside of here, you'll notice that new tag is not set to latest. And I didn't manually change this to version 1.0.1. Instead, this automatically happens during the CI stage, because this is the information that will be used to create the new deployment.yaml manifest file. And so I'm going to make use of YQ during the continuous integration stage to actually update this value. And this value will be taken from the package.json file, which actually has the version for our application. And then once this file has been modified, we can then run the Kustomize build on our dev overlay, and it will create a new deployment manifest file for us. So if I go to K8's manifest over here, where I'm actually exporting my manifests, you'll notice, if you draw attention here, that under the container configuration, we've got 1.0.1. So this was the file that has actually been created by Kustomize. And so my final manifest files will live inside of K8's manifests. Okay, so now let's actually take a look at the buildspec.yaml file, because this is where a lot of things will come full circle and you'll get to understand what's taking place inside of the continuous integration stage. And so if you followed along with the Terraform section, then you'll remember that I mentioned that CodeBuild makes use of this configuration file to know the different steps it should go through, as well as the software installation steps that need to take place. And so this is it's actually a container running inside of an EC2 instance in the AWS environment. And so I define the runtime versions that I want for my container, making use of Docker 19 and Node.js 12. And then I want to install a couple of packages which are going to be really important for the steps that I'll be working through in this stage. And I start off with installing Kustomize because we're going to be making use of Kustomize as our template management tool to modify our manifest file and give us the final output that we want. And then I'm also going to be making use of YQ for some modifications to the dev overlay manifest file that I showed you earlier. That's what's actually going to change the new version tag and add that in there before we run our Kustomize build command. And then I'm also importing my GitHub credentials. So CodeBuild needs to have access to your source credentials in order for it to authenticate with GitHub. And the reason for that is this is a separate process to CodePipeline actually pulling the source code from GitHub. CodeBuild will need to have direct access to GitHub as well if you want to clone a repository, and I'll be doing that in this step as well. And so in order to do that, I have to make use of the import source credentials command, which is a subcommand of AWS CodeBuild. And to do that, I have this import source credentials JSON file over here, and I'm specifying the server type, in which case it is GitHub. The auth type is a personal access token, but what I actually want you to see, which is really important, so definitely I'm going to need my username for my GitHub profile. You'll notice over here that I have token, and I'm just using a string token, which is not correct. You'll actually need to provide your personal access token in this case. And now, if you're going to be storing this inside of a repository like GitHub, which is what I'm doing, then you don't want to put sensitive data like that over there. So if you think back again to the the CodeBuild configuration inside of Terraform, I was providing my GitHub personal access token as an environment variable. And so that is this environment variable over here, GitHub token. And so I'm just using JQ to actually update the value for the token property inside of that JSON file for import source credentials. So that gets modified with the actual token. And then next thing, I can then run import source credentials and reference that specific file over there. And then you can run this list command just to make sure that things are set up as they should be. The next stage is I'm seeding into my application directory, and then I install the dependencies for my application because after that, I want to run tests. And this is one of the main purposes of continuous integration. It is to automate tests to make sure that you're only pushing out quality code. And so I run the npm run test command. If you remember to the earlier part of this code walkthrough, I actually showed you my application and the single test that has been created for the test endpoint. Provided that the test runs successfully, I'm creating an environment variable here called container image tag, and I'm pulling a new version. I'm pulling a version from the package.json file. So you could assume that you've gone through the normal development workflow or life cycle. You've changed your code, and because you're making changes to the code, you're going to do a version bump as well. So what I want to do is I'm just going to open this source app.js file. And you'll notice that I've now modified it from simple node app working, and I've added a version over here as well. So just a minor change to the source code so we can actually see a difference. And so I'm going to close that. And the other change I've made is to my package.json file. And I've now done a version bump from 1.0.1 to version 2 for the last one there in the semantic versioning. This is just a major minor patch kind of approach. Okay, so once that's done, that 1.0.2 will actually be stored inside of this environment variable. And then I proceed to create a new image, and I'm basically going through a Docker build stage over here. And once that image has been built, I log into the my Docker Hub account using my Docker Hub credentials. Again, these were environment variables that I provided to my CodeBuild environment during the Terraform stage. So I demonstrated that as well. And that pretty much sums up the build stage. And then for the post-build phase, once my image has been built, I push that through to Docker Hub. So Docker Hub now has my new Docker image, which is great. But we are still not able to actually make use of this inside of our Kubernetes cluster. So the next steps are to actually make sure that that happens. In order for that to happen, what I will actually need to do is I need to modify my deployment manifest file to now have this new container image tag so that when the CD tool is watching the GitHub repository, it can actually see that there's been a change to the deployment manifest file that it's continuously watching. And when it sees that, it will be able to deploy the new version to the Kubernetes cluster. So what I'm doing is I am cloning this exact same repository that you're seeing over here. I create a temporary directory, and then I clone it, and this is where the import source credentials comes in, so it will allow for this command to actually be executed successfully. I specify my username and my GitHub token over here, and once this repository has been cloned, I cd into the temporary folder where it has been cloned into, and then I cd into the customizations folder. So let me just collapse this so it's clear. This is the folder that I'm cding into. And if you'll remember what I said earlier, we want to make changes to the customizations.yaml file using the YQ command to update this to the new version. This is currently 1.0.1. So if I was to run the customize build command with this, it's simply going to create a deployment manifest file with the existing version, and we want the new version. So what I'm then doing is I'm making use of the similar command to what I run earlier, container image tag, and then I use this node command over here to get the version from the package.json file. And so at this stage, your changes would already have been committed to the remote repository, so that when once they get cloned, once it gets cloned during the CI stage, it will have the new version, which is 1.0.2, reflected inside of the package.json file. And so using YQ, I'll be able to modify the new tag property inside of that dev overlay manifest file with the environment variable container image tag, which I'm getting from my package.json file. And so YQ will update that customization.yaml file inside of the overlays dev. And so that's another step done. But the next thing is to actually run the customize build overlays, the customize build command with this particular overlay for the dev environment. And I'm telling it I want that to be the output to be exported to the K8's manifest directory with the deployment.yaml file. And once that's done, we are pretty much, we've completed our, the steps that we wanted to complete. The last thing is to just push those changes, because at this point, they would be local to the context of the CI stage and the container over there. So I commit these changes and push them through to the remote GitHub repository, as you can see over here. And once that is done, my CD tool, Fleet in this case, will be able, which is continuously watching that, will see that there's a change and deploy it. So Fleet will actually be watching this K8 manifest directory. At the moment, the deployment.yaml file has version 1.0.1, but once it's gone through, once our CI stage has completed, it will have the new version, and that's where Fleet will kick in. Now that we've done that code walkthrough, you'll notice that I have made two changes. The first was to the package.json file, specifying the new version for my application. In addition to that, I updated the response for the test endpoint from simple node app working to just having the new version specified there right at the end, just so we can actually have visualization of a change to our application. So what I'm going to do now is I'm going to commit these changes, and this will trigger the pipeline in AWS, and we want to make sure that the entire flow that I walked through during the buildspec.yaml file is actually working as expected. So I'm just going to go ahead and commit these changes. So I am inside of CodeBuild over here, and you will notice that my pipeline actually failed during the build stage, but it is for a good reason. I did not update the test. So if you think back to what I demonstrated earlier for the test that we're running, it is expecting a certain response, and you can see over here the reason it failed was it was able to detect that there was a difference in terms of the response that it's supposed to be getting. So simple node app working, specifying a version is not equal to what the old response actually was. So what I need to do is simply update this. And I've already done that. So you can see over here, I've modified it now so it will make sure that the string that gets the string response from the test endpoint actually has this new version. So I'm going to commit those changes and run the pipeline again. All right, so after that change, as you can see over here, my build status has now changed to succeeded because the pipeline runs successfully. And you can go through these logs provided that you go through this exact same setup on your end. But I'm not going to go through each of these line by line. It is very long, but essentially all the steps that we ran through worked successfully. And I'm just going to go through I want to show you in GitHub over here where the profile, or rather where the repository actually is. And you'll notice over here, I just want you to see the commit message, which is the one that was run inside of the CI stage, updated dev container image tag to 1.0.2. And we are particularly interested in, if you want to look at the customizations under overlays dev, I'm going to open up the customizations.yaml file, and you'll see that this was successfully updated by YQ. And more than that, what we wanted to make sure of was that the new deployment manifest file has the new version. And if I scroll down, you can see over there that it does have it. Now, I should mention that a very important thing that you should be aware of is that this design inherently won't work well with a pipeline, because if you're going to be exporting your final manifest files to this same repository, it will kick off the pipeline again. And so we don't want that. So the best thing is to actually have your manifest files be in a separate repository. But this will still give you a holistic picture of how you can get the CI/CD workflow. So it's not too much of a train smash. It still gets everything working. You just want to avoid having the pipeline being triggered again after you have pushed changes to the same repository in the post-build phase. And also, just so you can see over here in my Docker Hub account, I've got my new version over there, which is 1.0.2. So the next thing will be to take a look at Fleet. Finally, we come to the continuous delivery section, and I'm already signed into my Fleet Kubernetes cluster. As you can see, that is my current context. And so I've actually spun up 3 Kubernetes clusters. 2 are running in EKS setups, and 1 is with AKS and Azure. And so one of the EKS clusters is where my Fleet server is running, and the other 2 clusters are my downstream clusters. One is called Alpha, and that's the second EKS one, and the AKS cluster is called my AKS cluster. And so you can actually see that right now my Fleet server is already managing these other 2 downstream clusters. The top one is the EKS one, and the second one is the AKS one. You can see some sample nodes over here. If you're familiar with AWS and Azure, then this formatting should look a little familiar to you in terms of the node IPs. I'm going to switch over here to my browser, and what I want to draw your attention to, just to quickly see over here, this is my Fleet Kubernetes cluster, but then the second one is Alpha over here, and you can go to, if I go to the workload section and just come down over here, you can see Express API and Express Node.js. So this is my application. It has actually been deployed by Fleet, and if I click on that, I can get some additional information for it. You can see there are 2 pods running at the moment. And if I head over to my AKS cluster inside of Azure, same thing. When I go to the workload section, just head over there. If I head over to the workload section and see the deployments, then you'll see that I also have Express API running over here, which is great. And I've got the 2 pods running. But the next thing is obviously to test out accessibility of our application. Inside of my K8s manifest file, I also had a service. And so if I go to services and ingresses, and you might have already seen this earlier when I just came to the section, this is the Express service, and this is the external IP for that. And for on the Amazon side, I just have to head over to EC2 to get the load balancer IP. And so this is from the AWS environment. You can see the DNS over here, and that's the specific path for my application. And as you can see over there, I'm just going to zoom in a little bit. I have the response for my application. It is the new version. And if I head over to the load balancer that has been created inside of the Azure environment, I'm getting the exact same thing. So that brings everything full circle, just so you can see how we went from our application source code. I showed you the Dockerfile, demonstrated the infrastructure as code for the pipeline setup, and showed you the build configuration steps. And now just wanted to show you how my Fleet server running inside of a Kubernetes cluster is managing 2 downstream clusters and deploys the application to those respective environments. So we have a full CI/CD flow to deploy an application to Kubernetes. Thanks a lot for watching. If you found that helpful, please hit the like button and subscribe to the channel. Once again, if you want to connect with me, please check out the different links below in the description. And if there's a particular topic that you want me to cover, you can share in the comments section below.